Welcome to Kalika Steel, where world-class technology and state-of-the-art infrastructure converge to craft superior TMT steel bars. Scrap processing yard is the first step where metal sourced from various places like demolished structures and industrial waste are collected as raw material for TMT bar production. During sorting and separation processes, we use magnet separators to remove contaminants like plastics and non-metallic materials. At the core of our scrapyard operations, different grades of scrap are processed accordingly. Less dense scrap is compressed with bundle press machines for easier melting, and shearing machines cut long scrap into smaller pieces, breaking down large fragments for easier processing. High quality, low phosphorus, low sulfur DRI is separately stored and chemically tested for quality. The processed scrap is then transferred to the furnace area. The heart of the process lies in the induction furnace. Here, intense heat is generated by an induction furnace, melting the scrap into a molten state. During this process, impure metals surface at the top of the furnace and are removed in the form of slag to make sure we achieve the desired grade of the TMT bar. A key feature of our process is the neutral ramming mass. It is a specialized refractory material used in the lining of induction furnaces, providing a protective barrier that is resistant to high temperatures and chemically stable in the presence of molten metal and slag. This material is non-hazardous as compared to silica-based ramming mass and ensures a stable, inert lining crucial for maintaining the integrity of the steel. Our commitment to sustainability is evident in our advanced dust collection system. This system captures and removes particulate matter, dust and other pollutants generated during the melting process, ensuring that the fumes are purified to a level of up to 10 mg per cubic nanometer. The collected dust is stored in dust bags and then transported to a zinc extraction plant where the valuable zinc metal is recovered. This process underscores our dedication to achieving zero waste discharge in our operations. To achieve the required grade for the TMT bar production, the composition of the metal is closely monitored through chemical testing every 20 minutes during the melting process using advanced optical spectrometers. The spectrometer gives results within 10 to 15 seconds, indicating percentages of carbon, sulfur, phosphorus, chromium, copper, manganese, etc. Here, based on the test report, various alloying elements are added to the molten metal to impart better qualities to the steel. After the molten metal is transferred to the ladle, Radix powder is poured to hold the temperature of the molten metal while it is being transferred to the continuous casting process, the next step in our steel making journey. In the continuous casting section, the molten steel is transformed into billets, a semi-finished product with a constant cross-section. The process begins with molten steel poured into a refractory lined tun dish. During metal transfer, a shroud is placed to minimize air exposure, preventing metal oxidation and maintaining quality. This molten metal then flows into a water-cooled mold that is made of copper, where it begins to solidify against the mold walls. The continuously solidifying metal strand is gradually withdrawn from the mold through the use of a series of rollers. After leaving the mold, a partially solidified metal strand passes through an automated secondary cooling zone. Here, additional water sprays or other cooling methods are employed to further solidify the metal and control its temperature profile. Once the metal has solidified, it is cut at 12-meter lengths by automatic shearing machine. The billet size we manufacture is 150 mm by 150 mm, each 12 meters long and weighing 2.1 tons, a feat unique to our company. These cast billets are sent directly to the rolling mill, preventing them from cooling down. This process, known as direct rolling, eliminates the need to reheat cold billets which would otherwise require non-renewable energy sources like coal, oil and gas. By adopting direct rolling, we make our operations cleaner and minimize carbon emissions. Before entering the rolling mill, the billet undergoes induction heating. The induction heater ensures precise temperature control monitored by infrared sensors, enabling adjustments to the power supplied to the coils for maintaining optimal temperature. This not only results in minimizing scale formation, but also helps in optimal deformation throughout the rolling process. Meet the cutting-edge world of Kalika's slitting technology in steel rolling mills. Here, our heated billets undergo a transformative journey through 18 strands across 3 stages: roughing, intermediate and finishing. Each strand, equipped with 2 specially grooved rolls, precisely shapes the billet and reduces its cross-section to the desired final form. Shear cuts 1 and 2 enable precise removal of irregularities or uneven portions at material ends, ensuring that the material entering the rolling stands has uniform dimensions and is free from defects at the ends, resulting in improved surface quality. Loopers, a crucial component in our rolling mill, expertly manage material tension and speed. There are variations in the speed of the material going through different stands during the process of rolling. The loopers help compensate for these speed variations by adjusting the height of the loop and regulating the material flow accordingly, contributing to the overall efficiency and ensuring uniform section weight of the TMT bar throughout the rolling process. The true marvel of Kalika lies in our unique slit rolling technology. This innovative process, combining special roll pass design and precise guide equipment, efficiently splits a single billet into multiple strands, which then is further rolled into finished sizes. The slit rolling process enables Kalika production of 5 bars from 1 billet in 8 mm, 5 bars in 10 mm, 3 bars in 12 mm, and 2 bars in 16 mm. After finishing rolling of TMT rebar at a high temperature of approximately 950 degrees Celsius, the rebar passes through the Pomini quenching system, an exemplar of Italian metallurgical expertise used in the quenching process of the TMT bars. Here, the rebar is quenched to a temperature of approximately 350 degrees Celsius through controlled water pressure and air pressure adjusted according to the diameter of the bar. After the final quenching process, the rebar's temperature reaches approximately 520 degrees Celsius at the cooling bed. When rebar is quenched at high temperatures and cooled in air, it forms 3 distinct layers due to metallurgical transformation. First, the tempered martensite core on the outside provides high strength and hardness, making the bars resistant to wear and impact. This ensures that TMT bars can handle high stresses without deforming. Next, the mixed bainite core in the middle offers a balance of strength and ductility, absorbing shocks and distributing stresses evenly to enhance the bar's overall toughness. Finally, the ferrite pearlite core at the center ensures good elongation and flexibility, allowing the bars to bend without fracturing. This makes the bars highly bendable and weldable, perfect for various construction applications. At the dividing shear, the continuously rolling material is cut into specific lengths, essential for controlling the final dimensions of the TMT bars, then onto cooling. This automatic cooling bed efficiently cools hot-rolled TMT bars. Here, the inner core of the TMT bar cools naturally, giving the mechanical and bending properties. This is tested in the lab with the universal testing machine, which evaluates mechanical properties like yield strength, ultimate tensile strength, and elongation, providing valuable insights into the performance characteristics of your TMT bars. The entire water used in the steel making process is recycled, cleaned, filtered, and reused, minimizing the fresh water requirement. At our slag crusher unit, there is zero wastage or environmental discharge throughout the manufacturing process. The slag is crushed and reused after metal is removed as a substitute to river sand in construction sectors. At Kalika, our separate cut and bend unit precisely cuts and bends steel bars to the required dimensions and shapes for construction. With our advanced Steamer PEDEX German technology, ready-to-use steel accelerates construction timelines and ensures accuracy in measurements. By delivering ready-to-use steel, we reduce material handling on-site through neatly bundled and labeled goods. Our experienced team specializes in designing BBS from client-provided shop drawings, bringing expertise gained from diverse projects including windmills, metros, bridges and heavy-duty infrastructure endeavors. From scrap and sponge iron to premium TMT bars, Kalika Steel embodies a commitment to quality at each stage. Kalika Steel. Strength, assurance, heritage.